In this problem, we're going to look at these two compounds and determine whether each of them is aromatic, anti-aromatic, or non-aromatic. And just to quickly review the criteria for aromaticity, the molecule must be cyclic, it must be completely conjugated, it must have 4n plus 2 pi electrons, and it must be planar. If it's not cyclic, it's not completely conjugated, or not planar, it will be non-aromatic. If it is cyclic, completely conjugated, and planar, but has instead 4n pi electrons, then it'll be anti. So that's what we want to look at with these two molecules. And our first one here, we have this cyclic carbocation, so it is cyclic, but we want to look and see if it's completely conjugated. Well, let's draw an orbital picture for this. And I'm going to put a p orbital on every carbon that has a double bond. And a p orbital where there's a carbocation. So this molecule has a completely conjugated cycle of p orbitals. Okay, the next thing we can do is get a pi electron count. Well, we have these pi electrons and these pi electrons, so we have a total of 4 pi electrons. So now let's plug this into the aromatic equation, 4n plus 2. So we'll set 4 equals 4n plus 2. If we solve that for n, get 2 equals 4n, divide both sides by 4. N equals 2 over 4. That's not an integer number. We need that to be 0, 1, 2, 3, etc. to be aromatic. So let's check and see if it's anti-aromatic. We'll plug it into this anti-aromatic equation. So we'll set 4 equal to 4n. N equals 1. So this tells us that the molecule is likely anti-aromatic as long as it's planar, and a ring with 5 carbons doesn't have enough mobility to bend out of the plane, so this is planar. So it fulfills all the criteria for anti-aromaticity: cyclic, completely conjugated, planar, and 4n pi electrons. So now moving on to this next cyclic compound. It's another 5-membered ring. It has a positive charge. And before we look at all the criteria, once again we do have 4 pi electrons. So it's not going to fill the aromatic rule, or Huckel's rule. But for the anti-aromatic, again, we would get n equals 1, so it's starting to look to be anti-aromatic. But what you want to consider here is the nature of the cation. This cation is on a nitrogen, okay, but the difference here, in our first molecule, this carbon is sp2 hybridized, and the carbocation was in a p orbital. But now let's look at this nitrogen. This nitrogen actually has 1, 2, 3, 4 groups around it, so the hybridization of this nitrogen is sp3, each of these groups, or each of these bonds, is made from an sp3 hybrid orbital, and there is no p orbital on that nitrogen. In this case, the positive is simply a formal charge. So since there's no p orbital at that atom, we don't have a completely conjugated cycle. Since it's not completely conjugated, it's going to be just non-aromatic.